Look up at the night sky, and you might spot a brilliant, steady light. That's Venus, often called Earth's twin because of its similar size and mass. But this twin is hiding a dark secret. Beneath its thick, swirling clouds lies a world that is nothing short of a planetary inferno. Venus is the hottest planet in our solar system, with surface temperatures high enough to melt lead. Its atmosphere is a crushing, toxic blanket of carbon dioxide. It's a true hellscape, a far cry from the gentle blue we call home. Yet scientific evidence paints a startlingly different picture of Venus's distant past. Imagine a world not of fire, but of water. A world with vast, sparkling oceans, a mild climate, and perhaps, just perhaps, the right conditions for life. This isn't science fiction. This was likely the reality of a young Venus billions of years ago. It was once a world remarkably similar to early Earth, a true planetary sibling. So what happened? What catastrophic event or series of events transformed this potential paradise into the desolate furnace we see today? The story of Venus's demise is a chilling detective story written in its rocks and atmosphere. It's a cautionary tale that resonates deeply with our own planet's future. To understand Venus's tragic transformation, we need to travel back in time to the early days of our solar system, roughly 4.5 billion years ago. Both Venus and Earth were formed from the same swirling disk of gas and dust around a young sun. They were born as rocky neighbors, sharing a similar cosmic heritage. Early models suggest that for up to 2 billion years, Venus could have been a temperate world. It likely possessed a global ocean, possibly shallower than Earth's, but an ocean nonetheless. Its atmosphere was probably much thinner, with a climate that could have been quite comfortable, maybe even cooler than modern-day Earth. Evidence for this watery past comes from several sources. The ratio of deuterium, a heavy form of hydrogen, to regular hydrogen in Venus's atmosphere is a key clue. Because deuterium is heavier, it escapes into space more slowly. The incredibly high concentration of deuterium found on Venus today strongly suggests that the planet once held a massive amount of water, which has since been lost. Furthermore, data from space probes have hinted at the presence of granite-like rocks on the Venusian surface. On Earth, granite formation is intrinsically linked to the presence of water. This geological evidence supports the idea of a wetter, more dynamic ancient Venus, a world with continents and oceans. It was a planet on a similar evolutionary path to our own. So, with a similar start, where did the paths of these twin planets diverge so dramatically? The villain in this story is a phenomenon we are becoming all too familiar with, the greenhouse effect. Every planet with an atmosphere has a natural greenhouse effect. Certain gases, like carbon dioxide and water vapor, trap heat from the sun, keeping the planet warm enough for liquid water and, in our case, life. On Earth, this process is balanced. Oceans, rocks, and life itself work together in a complex cycle to regulate the amount of carbon dioxide in the atmosphere. But on Venus, this delicate balance was shattered. The planet entered a runaway greenhouse effect, a positive feedback loop from which there was no escape. It all started with the sun. Over billions of years, our star has been gradually getting brighter and hotter. As the sun's energy output increased, Venus, being closer than Earth, received more intense solar radiation. This caused its oceans to begin evaporating at an accelerated rate. Water vapor is a powerful greenhouse gas. As more water evaporated into the atmosphere, it trapped more heat, which in turn caused the oceans to evaporate even faster. This created a vicious cycle. The planet got hotter, more water turned to vapor, and the atmosphere became a thick, heat-trapping blanket. Temperatures began to soar, reaching a critical point where the oceans literally boiled away, sending all of the planet's water into the atmosphere. This massive injection of atmospheric water vapor was just the beginning of the catastrophe. In the upper atmosphere, the intense ultraviolet radiation from the sun went to work. This solar radiation split the water molecules into their constituent parts, hydrogen and oxygen. The light hydrogen atoms, being so nimble, easily escaped Venus's gravity and bled off into space. This process, known as hydrodynamic escape, was irreversible. Once the hydrogen was gone, the water could never reform. Venus lost its oceans forever. Oxygen left behind likely combined with carbon on the surface or was stripped away by the solar wind, leaving the atmosphere fundamentally altered. With its oceans gone, Venus lost its primary mechanism for regulating atmospheric carbon dioxide. On Earth, our oceans are a massive carbon sink, absorbing vast quantities of CO2 from the air. Without this crucial buffer, another even more potent feedback loop was triggered. The rising surface temperatures started to bake the planet's crust. Venusian rocks, rich in carbon compounds, began to release their stored carbon dioxide directly into the atmosphere. This is sometimes called the Great Bake-Off. Volcanic activity, which may have been rampant on the planet, would have pumped even more CO2 and other greenhouse gases like sulfur dioxide into the already choked atmosphere. The planet was now in a full-blown runaway greenhouse state. The atmosphere grew thicker and thicker with carbon dioxide, reaching pressures over 90 times that of Earth's at sea level. Imagine the pressure you'd feel nearly a kilometer deep in our ocean. That is the pressure you would experience just standing on the surface of Venus. The temperature skyrocketed to over 460 degrees Celsius, or 860 degrees Fahrenheit. It became a uniform, scorching heat that blankets the entire planet, from the equator to the poles, day and night. The beautiful, life-giving water vapor had been replaced by a dense, toxic smog of carbon dioxide and clouds of sulfuric acid. The transformation was complete. The once temperate twin of Earth had become a sterile, superheated pressure cooker, a planet suffocated by its own atmosphere. The story of Venus serves as a profound and sobering warning. It demonstrates that a planet's climate is a fragile system, and that a world like ours is not guaranteed to stay this way forever. While Earth is not in immediate danger of a Venus-style runaway greenhouse effect, we are farther from the Sun and have different geological cycles. The underlying physics are the same. The destruction of Venus highlights the immense power of greenhouse gases to fundamentally alter a planet's climate. It shows us what happens when a climate system is pushed past its tipping point. The rapid increase of carbon dioxide in our own atmosphere, driven by human activity, is pushing Earth's climate into uncharted territory. We are, in a sense, conducting an experiment with our own planet, and Venus shows us what the worst-case outcome of such an experiment could look like. Studying Venus is not just about understanding another world. It's about understanding ourselves and the delicate planetary balance that allows us to thrive. By unraveling the mysteries of Venus's past, we gain invaluable insights into the forces that shape planetary climates, including our own. It provides a crucial data point in our quest to understand habitability. Future missions to Venus aim to dig deeper into this history. They will analyze its geology and atmosphere with unprecedented detail, searching for more definitive proof of its ancient oceans and learning precisely how its climate collapsed. Understanding Venus's journey from a temperate, water-rich world to a toxic inferno is one of the most important goals in planetary science. It's a story of a paradise lost, a stark reminder of the cosmic tightrope a habitable planet must walk, and it urges us to cherish and protect the delicate, life-sustaining climate of our own beautiful blue world. For more deep dives into the mysteries of our solar system and beyond, make sure to subscribe to Space Repo.